So in today's question, find the time of an aeroplane having velocity v takes to fly around a square with side A. The wind is blowing at a velocity u in two cases. So there are two cases. First is if the direction of wind is along one side of the square, and the second case is if the direction of wind along one of the diagonals of the square. So in the case it is suggested that it consists of two parts, part A and part B. Okay, so let us first of all draw part A. Let us draw the square whose side is A. We start from A, B, C and D. So the plane will be starting from, okay, so in this case the plane will be flying in this direction from A, this, C and finally return to point A. Okay, so you can say that plane is flying A to B, B to C, C to D and again D to A. And we assume that, and its velocity is given that it is given by V. Okay, you can say that I think its relative velocity is given. Velocity V is given. So we write velocity of the plane, velocity of the plane is V, and in the first case it is said that direction of wind is along one of the side. So we assume that let the wind direction is along the side AB, and the velocity of the wind is given as u. So we are going to divide A into 4 parts, one for each side. Okay, so let us consider first case for side AB. Okay, for side AB, so for AB, this is side AB. The velocity of the plane V is in this direction, and velocity of the wind U is also in the same direction. Okay, so we can say the relative speed of the plane, you can say relative speed of the plane will be equal to V plus U. Okay, because both are following in same direction. Okay, here we can write plane and wind, rather we can say direction of, okay, direction of plane and wind is same. Okay, direction of plane and wind is same. So we get relative speed of plane will be given as V plus U, and the time taken by the plane from A to B. Let us call this as TAB, and we can say TAB will be equal to distance, that is A, divided by U plus V. So this is the first side AB. Let us call this equation 1. Now second, for side BC. For side BC, so BC, the plane will be flying in this direction, but actually we want that plane should be flying in BC direction, okay, and the wind will be flowing in this direction, that is U. So in order for the plane to be actually flying in BC direction, it should be flying in at an angle with BC. Okay, so this will be the, let us call this as C prime. So this will be the actual flying direction of the plane. Okay, so we can write it here. BC prime is the actual flying direction of the plane, so that the resultant flying direction of the plane coincide with the side BC. Coincide with side BC. Okay. So this is, we can say, B prime C is V, and wind is flowing in this direction, that is given as U. Okay, so we can find out that, let us call this as VR, resultant. Okay, so the actual velocity or resultant velocity of the plane. Okay, you can say the resultant velocity of the plane is equal to VR, that will be equal to V square minus U square and its square root. Okay, so you can say time taken by the plane from B to C. Okay, if we say this is TBC, then TBC will be equal to distance divided by its velocity, V square minus U square and its square root. This is equation number 2. For case third, we can say side CD. For side CD, so now the plane will be flying along this direction. This is point C, this is T. Okay, this will be velocity of the plane, and the wind will be flowing in this direction, that is u, in opposite direction. So we can say that the speed of the, or rather velocity of the, velocity of the plane, velocity of the plane will be equal to v minus u. So we can write the time taken by the plane from C to D. Let us call this as TCD. This TCD will be equal to A divided by V minus U. This is question number 3. Fourth question, side DA. So inside DA, once again, we want that the plane should be flying in this direction DA, but we know that the wind velocity is in this direction u, so the actual direction in which the plane will be flying will be this DA prime. So this will be V, and this will be our u, and we want, let us call this as VR prime. Okay, so we can write it here that for the plane to be flying along the side AD, actual flying direction of the plane should be dA prime. Let me write it as a side dA. Okay, so actual flying direction of a plane should be dA prime. So which implies that resultant V prime will be equal to V square minus U square and its square root. So time taken by the plane from D to A, if it is given dt dA, then t dA will be equal to A divided by V square minus U square. Now we have to find our total time. So we are, okay, let us call this as equation number 4. So we are going to find our total time. So total time will be nothing but summation of individual all the times. Okay, therefore total time around the square is T, this will be equal to TAB plus TBC plus TCD plus TDA, and we put the values. TAB was A divided by U plus A, TBC was A upon V square minus U square and its square root, plus TCD was A V minus U plus A upon V square minus U square and its square root. Now this is now simple arithmetic calculation now. So we can write that the time t will be equal to, let us take the LCM, v square minus u square, okay, and this will be coming as 2ab plus 2a v square minus u square and its square root. So if we rationalize this part, v square minus u square, v square minus u square, so we are going to get t 2ab v square minus u square plus 2a v square minus u square and its square root divided by v square minus u square. So finally this will be equal to, we can take 2a v square minus u square as, we get v plus square root of v square minus u square. This is time t, so this is time in the first case, total time taken by the aeroplane when the wind is flowing along the diagonal. Now the second, in the B part, wind direction is along the diagonal. Wind direction is along the diagonal. So let us draw the diagram. We have A, B, C and D, and we assume that the wind direction is along the diagonal AC, along the diagonal AC. So in this case, just remember that this AC is going to have two components, okay, so we can divide. Let us suppose this is AC. This is always going to have two components. Let us call this as x-axis and this is y-axis. So this will be x and this will be y. This angle will be 45 degree. So it is going to have two components and its velocity is given as u. Okay, so we can say that this component will be ux, which will equal to u cos of 45 or p square root 2, and one component will be u of y, that equal u sine of 45, and this will be equal to u divided by square root of 2. So it is always going to have two components. So let us start by, we say along AB. Along AB means plane is flying along AB, plane direction. Now if the plane is flying, what we want, that plane should be flying in this direction AB, and we already know that this is in that direction u. Okay, so the wind direction is at an angle of 45 degree, so it is always going to have two components. Okay, so we can, one component will be in this direction, that is ux, and another component will be in this direction, that is u of y. So if you want that a plane should actually be flying in the direction of AB or along the side AB, its actual flying direction will be this one, in this direction, B prime. So this will be its actual direction v, this is ux, okay, and let us call that the vr is the resultant velocity in this direction, and there will be two components of the velocity. One is wind velocity also, so wind velocity will be also having its component vy in the same direction. Okay, so this is the basic thing here. At every point we can say, every point of the plane there will be always two components acting, one be in the vertical direction, another one will be a horizontal direction. So the final motion of the plane will be depending on the both the components. Okay. So we can write, if the final flying direction of the plane should be along AB, then it should be actually flying in the direction AB prime. Okay, it should be actually flying in the direction AB prime. Next we can write, there will be we can say component of wind velocity, that is ux and uy acting on the plane. There will be a component of wind velocity, that is ux and uy acting on the plane. Okay. Next we can write, if vr is the resultant velocity of the plane, due to we can say uy, then vr will be equal to we can say we have resultant component, okay, v minus their square and square root. So we put the value of ux is u upon square root of 2, so we get v square minus u square divided by 2 and its square root. Okay, so we found out that vr is, next vertical component of the velocity of the wind velocity will be in same direction in which plane is in the direction, same direction AB, that is along VR. Okay, so we can say, thus the velocity of the plane will be equal to VR plus Uy. VR we already know is given as, let us call this as VAB. So VR, we already know, is V square minus U square divided by 2, and plus UY is U divided by square root of 2. Okay, thus the time. Therefore, TAB will be equal to A divided by V square minus U square divided by 2 square root plus U divided by square root of 2. Let us call this as equation. I don't think there is no need to put the equation. Okay, it's crystal clear. Second case, along BC. Okay, so what we want now, we want the plane should be flying in BC direction, and once again there will be two components of the velocity. Okay, there will be two components of velocity. The actual wind direction is given in this direction, that is U. So it is going to have two components, Ux and Uy. So if you want that of a plane should be flying in BC direction, the actual direction in which it should be flying will be given as BC prime. Okay, so this will be our V. And once again this will be our Uy. Okay, and let us call this as VR, and Ux will be also in the same direction. So now we can directly write all the things. There is no need to explain again the entire theory. So we understood the thing that we want that plane should be actually flying in the BC direction. The wind direction is starting from point A in this direction. Okay, so ultimately it is going to meet C. So U is going to have two components, Ux and Uy. So Ux will be supporting the velocity of the plane, whereas Uy will be trying to push the plane, or rather say because of vertical component there will be a drift in the plane. So the plane should be actually flying in this direction, BC prime. So we can directly write now that VBC will be equal to VR plus Ux, and from VR we can write here VR will be equal to V square minus U square divided by 2, and Ux we already know is given as U divided by square root of 2. So VBC is VR, that is V square minus U square divided by 2, and plus U divided by square root of 2, that is VBC. Thus the time TBC will equal to A divided by V square U square divided by 2 plus U divided by square root of 2. This is our VBC, rather TBC. In the third part, we have along CD. So now the plane should be actually flying in this direction, CD, and wind is in this direction. Wind direction is this one, this is point A. So again it is going to have two components, Ux and Uy. Okay, so Ux will be creating a drift in the plane, so the plane should be actually flying in this direction, that is CD prime. Because of that, and now we have VR in this direction and Uy will be in opposite direction, and this will be our U of X. let us call this as v. So now VR, resultant velocity, is v square minus u square divided by 2, and we have uy is equal to u divided by square root of 2. Okay, so we have we get VCD will be equal to VR minus, because they are in opposite direction, u of y. VR we already know is v square minus u square divided by 2 and minus u by square root of 2. This is VCD. Next we find out TCD. Okay, we can say that TCD will be equal to A divided by v square minus u square divided by 2 minus u square root of 2. This is TCD. And finally, that's the fourth one. Okay, we can say side DA. So now we want that the plane should be flying in this direction DA, but the wind direction is this direction. Okay, this is U. So once again it is going to have two components. One component will be in this direction UX, and another component will be in this direction, that is UY. Okay. So what we want, that we want the plane should be actually flying in the DA direction. So the actual flying direction of the plane will be DA prime in this direction with V. Okay, and we are going to have this component will be called UY. So we have to get V resultant in this direction. Okay, and UX in opposite direction. So we can write VR is equal to v square minus u square divided by 2, and ux will be equal to u divided by square root of 2. So velocity along AD, that is VAD, okay, will be equal to VR minus ux, both are in opposite direction. VR we already know is given as v square minus u square divided by 2 and its square root, minus ux is given as u square root of 2. So time TAD will be equal to A divided by v square minus u square divided by 2 and its square root minus u divided by 2. So this is the fourth time. Finally, we are going to add all the times. So we can say total time taken along the sides of the square by the plane. Okay, so we will add all the times. T will be equal to TAB plus TBC plus TCD plus TDA. And TAB, we found out that TAB was equal to A divided by v square minus u square divided by 2 plus u square root 2, plus TBC was given as A v square minus u square divided by 2 and plus u divided by root 2, and plus TCD was, TCD we calculate here, that is A divided by v square minus u square divided by 2 minus u square root of 2 and finally that is TDA is given as A divided by V square minus U square divided by 2 minus U divided by square root of T. 2, sorry, this is T. Now the thing on the left is simple mathematical calculations, so we can solve it, and its solution will be given as T is equal to, we take A as a common, and 2 divided by V square minus U square divided by 2 and its square root plus U divided by square root of 2 plus 2 V square minus U square divided by 2 and minus U divided by square root of 2. Now we take the LCM, so this will be equal to A, so LCM will be A square minus B square, so we get V square minus U square divided by 2 minus U square divided by 2, and we can take also 2 common, and we are left with V square minus U square divided by 2 minus U divided by square root of 2 plus V square minus U square divided by 2 plus U divided by square root of 2. So these two cancels out. We are left with 2A, and this will be coming as 2 V square U square divided by 2 and its square root divided by V square minus U square. Now we take, this will be 4A, we take 2 as LCM, this will be square root of 2 outside, we get 2V square minus U square square root of 2 divided by V square minus U square. Okay, now we divide and multiply by square root of 2. We get this as 4 square root of 2A divided by 2 to V square minus U square and V square minus U square square root. So finally the time total will be coming as 2 square root A to V square minus U square square root divided by V square minus U square. Okay, so this is our final answer, that the time taken by the plane in two cases, that when the first the wind direction is along the side, and the second when it is along the diagonal. Thank you.